Molar volume is, well, yes, there's a couple constants go with it. There's a formula that goes with it. But if you think about this, remember we talked about Dalton's law of partial pressure? We said, what are the only things that can change, right? That's kind of what we're going to do with this here as well. Look, if you have, let me just scroll up here for a sec. I'm going to pick some specific conditions here just for a second here. Now, I don't have to pick these conditions, but it doesn't really matter, but I might as well do this, okay? Let's pick STP, so standard temperature and pressure, STP. So 101.325 kilopascals, and over here I'd put in my 273.15 Kelvin, okay? Guess what? If you take any gas, so remember, what is gases? Gases are mostly empty spaces. Gases are incredibly small molecules, just like all molecules are, but they're incredibly small, okay? When you think about gases, they fill to take on their container. So what determines the volume for a particular gas? Well, pressure can determine the volume. That's Boyle's law, yes? Okay? Pressure increases, volume gets smaller, right? True? Right? What else can determine the volume of a gas? Well, temperature can determine the volume of gas. Volume and temperature, that's Charles' law. Charles' law says temperature goes, if the temperature goes down, then the volume goes down, okay, of a gas. If the volume goes up, the temperature goes up, if we want to keep the pressure the same. So using the fact that P and V and T, all those things are related. In fact, they're all things that we call the combined gas law, which we've done before. Those things are all related to each other. If we change the pressure, then we change the volume. And if we change the temperature, we're changing the volume. So what we're saying here is that these three things are related. And look, they are related. In fact, they're always directly related. Why is that? Because look, if you take any gas, and I'm talking any gas, propane at the fuel station, so you could take propane, C3H8, okay? Or you could take one of the smallest gases we know, which is hydrogen, HH, okay? It doesn't matter what gas you take. But if you take the same amount of that gas, 1 mole of that gas, for example, if we take 1 mole, now some of you guys will say, I want to take propane, and somebody else would say, I want to take some hydrogen. I don't care. If you take 6.02 times 10 to the 23 molecules of that gas, and you stick them in at 101.325 kilopascals and 273.15, you always get the same number, of course. It doesn't matter what gas you use, you will always get this number here, which is called 22.4 liters. How do I know that? Because I solve for V. Don't believe me? Solve for V. 1 times 8.314 times 273.15 divided by 101.325, it's 22.4. Every gas at standard temperature and pressure will occupy 22.4 liters for every mole of that gas that you have. Look, if you have 2 moles of gas and you want to keep the same pressure and the same temperature, well, guess what? You need twice the volume to do that. Okay? So you would need 44.8 liters, in other words, to occupy those 2 moles of gas, if you want to keep the conditions the same, pressure and temperature. And if you took a half a mole of any gas at STP, you only need to have 11.2 liters, okay, of volume to keep it at that pressure and that temperature. All those things are related to each other. And that is something called molar volume. Why do we call it molar volume? Molar, moles, volume, liters, okay? How many liters per mole of gas is occupied here? How many liters does it take to occupy 1 mole of this gas? Turns out that any gas, 1 mole of any gas, will occupy 22.4 liters under STP conditions. What if we talk about different conditions, perhaps, maybe at SATP? Well, we'd have to change the 100 kilopascals, right? If we want to talk about a mole of any gas, fine. And 298.15 Kelvin. Well, what's this going to be here? It works out to be 24.8 liters. So at SATP, that's pretty much a constant. For every liter that you have, or every mole that you have of a gas, it requires 24.8 liters under those specific conditions. Okay? Because remember, you can't change the pressure. If you change the pressure, you're going to change the volume. And if you change the temperature, you're going to change the volume. So under these specific conditions, that's a constant. It has to occupy 24.8 liters. Okay? So those are kind of some constants, and that's what we call molar volume. Molar volume, by the way, it's right here as well. There's a little chart here for you. And basically what it says here, 1 mole of H2 will occupy the same volume as 1 mole of C3H8 under the same temperature and pressure. Why? Because gases are mostly made up of or consist of empty spaces, right? The molecules themselves are very, very tiny. So what it depends on is the pressure and the temperature. If those two things are the same, then the volume has no choice but to be, in the case of STP, 22.4 liters for every mole of gas that you have. You might say, when would I possibly ever use this? Well, let me give you a quick little example here. 4.04 grams of hydrogen at STP. What is the volume? Now, can you do this question using PV equals nRT? Do you have enough information? Can I find the volume using PV equals nRT? Sure you can. nRT over P, yes? Right? Do you know N? Well, you could figure it out. Do you know R? Yes. Do I know T? Yes. Do I know P? Yes. You could do that, okay? But I'm telling you, there's a shortcut here a little bit. Look, if I have 4.04 grams and I divide it by the molar mass, I have 2 moles of hydrogen at STP. Guess what? 2 moles of hydrogen at STP, any gas at STP, hydrogen, oxygen, nitrogen, is going to occupy 22.4 liters for every mole of that gas. That's a guarantee. Okay? I just did it on the other page with PV equals nRT. 22.4 liters per mole. If I have 2 moles, multiply it by 2, and you're done. 44.8 liters is how much volume that gas would occupy. Okay? It's that much. That's how many liters you need for a mole. If you have 2 moles, you need twice the amount, twice that volume. If you have half a mole, you need half the volume. Okay? That can save you a lot of time in some cases doing these questions. All right? Where do we get molar volume from? Well, it's based on PV equals nRT. So, not every time do you get STP or SATP, although I'll tell you right now, if it's a question on the test, for example, coming up here, I will probably put it STP and SATP so that those of you guys that understand molar volume and have been paying attention here will have a little quicker way of getting this done, so you can move on to other stuff. Okay. Having said that, you can still use PV equals nRT. It's just going to take maybe perhaps a little bit longer. Okay. Sometimes they're not at STP or SATP. So what do you do in this case here when it talks about molar volume? There's 2 formulas that'll do molar volume for you. They're on the back of your periodic table. So we probably should write those down. There is this one here, RT over P, and there's this one here, V over N. Okay? You're going to use one of those 2 formulas. Which one do you need to use? Well, it depends on the information you're given. Okay? If you're talking about volume and moles and stuff like that, I'd probably use the one on the right. If you're talking about pressure and temperature and you see that kind of stuff in the question, or you're looking for temperature or pressure, I'd probably use the one on the left. Okay. By the way, this stands for molar volume. And the units that go with unit molar volume are always liters per mole. When you see liters per mole, you will know that this is a molar volume type of question, and that you probably should use one of those two formulas. Okay? One of those two formulas. All right? Same thing over there, of course. What's RT and P? Well, that comes from the ideal gas law. So 8.314, the temperature has to be in Kelvin, the pressure has to be in kilopascals. The volume over there has to be in liters and has to be in moles, as always. It comes from PV equals nRT, just like I showed you earlier. And this is in the same lesson, so obviously ideal gas law, PV equals nRT. So looking at this one here, calculate the molar volume of neon at 150 and 36.5. They're telling you the pressure and the temperature. If I was doing this question, I'd probably say, you know what? I probably should use this formula here. Calculate the molar volume at 36.5 temperature, 36.5 degrees Celsius. You, of course, want to change that to Kelvin. 309.65. And a pressure of 150, and of course that has to be in kilopascals, which it is. And if you solve for that there, you get 17.16 or 17.2 liters per mole. Okay, final answer. 3 significant digits, of course, because there's 3 in this question. So I just use that simple formula to calculate the molar volume. Calculate the molar. When you see molar volume or you see liters per mole, it's one of these two formulas probably that's going to help you out. Okay. This one down here, it tells you the molar volume is this. Look, I see liters per mole, molar volume. Okay. What volume? So when I think about this, I think, which formula is best going to find the volume for me? Probably this one here. So I'd want to use this formula for this. Once again, both of these are on the back of your periodic table. Okay, so no excuse there. If I want to find the volume, how am I going to do that? I'm going to cross multiply. Remember, this is one variable there. It's called molar volume. Okay, we can't use big M. We can't use V because big M is molar mass. V is volume, liters. This is not that. This is molar volume. It's all one thing. Okay. So, cross multiplying, and I have basically the molar volume times N. Okay? Well, I know the molar volume. It says right there, the molar volume of argon is 24.79 liters per mole of argon, okay, at SATP. What volume will be occupied by 100 grams of argon? So, I need to know N here, of course. Once again, anytime you need to know N, you probably should be using this formula here. N equals little m over big M. So 39.95, I think, is argon. Grams per mole. And that'll give you N for there. And it works out to be about 2.50, I think. Let's see. No, 39.95. All right, 2.503, etc., etc. And that, of course, is moles. So I have about 2.5 moles of argon, and if I know that if it occupies 24.79 liters for every mole, multiplying those two will tell me the volume of argon that I would expect to have. Okay? Which works out to be 62.05 liters. 4 significant digits in this one, because of course there is 4 in my question as well. Okay? So that's a little bit about molar volume. All right. Questions, anyone? Like I said, formulas are on the back of the periodic table. Okay.